Welcome everyone to this lecture on Matplotlib basics. The most basic way to use Matplotlib for visualization is through the simple function plot calls, which after you import matplotlib.pyplot as PLT, then you'll simply call plt.plot and pass in the x and y you want to plot. And these function calls are really simple to use, but they don't actually allow for very high degrees of control. So we recommend using these simple plt.plot calls for quickly visualizing relationships and data. However, later on, we're going to be exploring the more robust object-oriented programming Matplotlib figure API. So keep in mind, we're going to first show you the simple functional way, and then we'll move on to the more advanced OOP way. As a quick note, there's going to be some slight differences in displaying plots within a notebook versus running a Python script. So if you've been following along in your preferred IDE, which runs .py files or .py scripts, instead of the notebooks, you're going to need to add plt.show command discussed later on in this video in order to actually see your plots in a new window. If you're using a Jupyter Notebook-based environment, then you'll actually be able to see the plots show up right underneath the cell itself. So keep that in mind, and we will discuss this in the video. Speaking of which, let's go ahead and jump over to a Jupyter Notebook and show you how to actually work with Matplotlib basics. Okay, here I am at the Jupyter Notebook. The first thing we need to do is import matplotlib.pyplot. So we're going to say import matplotlib, and then we call .pyplot, since we're actually working with the pyplot portion of the total matplotlib library. And then by convention, we import this as PLT. Keep in mind, it's a super common mistake for beginners to forget this .pyplot section, so just remember that it's matplotlib.pyplot as PLT. Okay, so now that we've imported the plotting capabilities of Matplotlib, we should be able to plot. As a quick note, I mentioned that if you're running this as a Py script, at the end of your plots, you'll have to say plt.show, and we'll show that in just a second. And another note, if you're running an older version of Jupyter Notebook than what we have in the provided environment, you may need to run the magic cell command, matplotlib inline, if you're not actually seeing the images show up. There's actually a full explanation of this in the lecture notebook, so don't worry about this right now. If you do encounter those issues, just go ahead and read the explanations in the lecture notebook for quick fixes. But right now, if you're following along with the course environment, you should be fine just importing matplotlib.pyplot as PLT. So let's start with a very basic array plot. Essentially, we're going to have some data and then we want to plot it out. To make some data, I will import NumPy as NP, and let's make a simple x and y array. I will say x is equal to np arrange, let's say from 0 to 10, and now let's go ahead and make a formula like y is equal to 2 times x. So y is equal to 2 times x. Alright, so I have my x array, 0, 1, 2, all the way to 9, and then y is simply double of that. So we have this linear relationship, y is equal to 2 times x, and now I want to plot it out. Well, using the functional method calls, the easiest way to do this for just a quick visualization is to say plt.plot. And what's a little annoying with the documentation is plt.plot is actually a very large function calling many other things behind the scenes. So the documentation string can sometimes be a little overwhelming because it's not very clear from plt.plot exactly what you should be passing in. It just says args. But if you expand on this, it starts giving you various examples of call signatures. And in fact, if you start scrolling down, it just gives you this huge list of documentation of different ways to plot stuff. So we're going to kind of go through this step by step. But the main way is essentially what it shows up here, which is just plot an x point versus a y point. So this is the default line style. And then later on, we'll see that we can actually add in markers, etc. So we're going to say plt.plot. You're going to plot your x versus your y. And then, if you're running this correctly, I'm very zoomed in right now, so you can zoom in one level out so we can see the plot here. So now I can see here that Matplotlib has created a linear plot between the coordinates. So I have this linear relationship, y equals 2 times x, which means I have a bunch of x and y coordinate points, 0, 0, 1, 2, 2, 4, 3, 6. And so what Matplotlib has done is it drew all those points and then drew a connecting line between them. And later on we'll see how to just do the points themselves, maybe how to do a dashed line, etc. So keep in mind, this is just a very simple linear plot. And later on we'll see how we can customize it. But a really common question I get right now is if you're running a .py script, I don't see the visualization. And if that's the case, you simply need to add plt.show, open and close parentheses. And if you run this, For Jupyter Notebook users, they won't really notice a huge difference, but this is necessary if you're running it as a .py script. Now, people that were paying attention should have noticed that as soon as I added plt.show, I actually didn't see a little extra output. In fact, if we remove plt.show, you'll notice that I get this output of Matplotlib lines line 2D. However, the second I add plt.show, then I just get the visualization itself. So a really common question is, what's actually going on here? Well, essentially, plt.plot is doing two things. It's returning this array of Matplotlib align 2D object at this location in memory, and it's rendering a visualization. So Jupyter Notebook, the way it works internally is it shows you both the actual object that's being returned at what location in your computer's memory and the rendering of the visualization itself. So in order to only see the rendering of the visualization, you can either add plt.show, or for notebook users, they can add a semicolon, which basically says, just show me the visualization itself. It's kind of up to you whether or not you mind seeing this output of the object. It's just reporting the object type. In this case, it's quite clearly a 2D line object, and then it's at this location in your computer's memory. And as I just mentioned, plt.show is necessary if you're running this as a .py script. Okay, so now what can we do to edit this Matplotlib functional commands? Well, we can do things like add an X label, Y label, and title. So let's go ahead and try that out. If I want a title at the very top of my plot, I can say plt.title and then just pass in a string for my title. So this would be whatever string you want. You go ahead and run this. Let me put a semicolon at the very end of this. That way we only see the rendered visualization, and there's my string title. And in a second, later on, we'll actually talk about how to make this a little less blurry by adding more dots per square inch. Okay, so we know how to do a plot, how to do a title, and let's go ahead and add an X label and a Y label for those axes. It's simply plt.xLabel, and then let's just go ahead and say x-axis, and then plt y-label, y-axis. And a really important thing to note here is if you're using Jupyter Notebook, these should all go within the same cell. Otherwise, you'll get errors because Matplotlib won't be able to connect the label to the plot. So we'll go ahead and run this, and we can see here we have our string title, and then a y-axis label and an x-axis label. So what other figure parameters can we start to adjust? There's a lot of figure parameters we can actually adjust, but let's show you the most common ones. One is to adjust the x limits and y limits. You'll notice right now by default, it actually shows you a little past the points themselves. So if you have a point at 0, 0, it's actually going to show you a little past that along the axis. We can see a little bit of negative along y-axis and a little bit of negative below 0 along the x-axis. Sometimes that bugs people, so we can simply add limits, and the way this works is you say plt xlim for x limits, and you provide a lower limit and upper limit. So for example, right now we're going from negative, maybe -1, or actually less than that, a little less than 0, and then we're going beyond 8. So let's imagine I wanted to have a hard cutoff on the x-axis at 0, and then maybe I only wanted to go up to 6. So if you run that, note what's going to happen here. I'm going from a little below 0 to somewhere around 10. If I run this, now my x-axis has been cut off. That only goes from 0 to 6. So you can set your own limits for what is displayed on the actual rendering. Keep in mind your data may go beyond those limits, but it's really up to you. Okay, and then we can also say plt y-limit, and then let's go ahead and edit that one to maybe between, let's say between 0 and, I don't know, 15, for example. And you can see that, and then you can adjust the axes as necessary. So keep in mind, here we're actually cutting off data points because we have data points that go beyond 6 along the x-axis, 7, 8, and 9, and those corresponding 14, 16, 18 points. But this is just kind of the way to zoom in yourself with x limits and y limits. All right, so now let's talk about saving a plot. You can just actually call a plot, and then right after it, call plt.savefig. So the way this works is, let's say you've gotten your x label and y label set up. You're comfortable now with the limits you set, and you did a title. And now you want to save this plot as a PNG file. Well, I'd encourage you to actually call help plt.savefig, and you'll see the various parameters you can call, such as DPI, fname, etc. So there's lots of things you can do here, affect the quality, dots per inch, but right now we're going to not worry about that and just show you how to save the raw image itself. So we've already rendered this image, and now I want to save it as a file. Matplotlib supports all major file types, so things like PNG files, JPEG files. You simply just need to provide it when you're talking about the file name. So in the same cell, after doing your plots, doing your labels, your x limits, and your title, simply say _plt.saveFigure, and then we can save this as my first plot .png, or if you want .jpeg. It's up to you. I'll go ahead and do .png, and then keep in mind, if you want to save this somewhere else on your computer, you would just provide the full file path. For example, a Windows users could do something like this. C users, then my username, etc., desktop, and keep going to wherever they wanted this to be saved. If you just pass in the file name itself, it's going to be saved in the same location as wherever you're running your Python code. Okay, so we'll say plt save figure. We go ahead and run this. We actually still get to see the plot within Jupyter, but now if I say file open and scroll down here, I should see here, created seconds ago, my first plot.png. Go ahead and click on that, and we see here my first plot. All right, so that's how you can save a plot. I know that we haven't covered that much as far as customization, but really, this is just to show you the basics of creating a figure. If you want to start getting more complicated, you should start moving on to the object-oriented programming method using the figure object. So for the functional method, this is pretty much all we're going to cover, because you should only be using this method for kind of a quick and dirty plot to do something like plot out a linear relationship. Again, as far as the functional method is concerned, we only need you to worry about this list of commands here. Plotting it, labeling your x and y axis, setting limits, setting a title, and then saving the figure. This is the functional programming method for Matplotlib. Now, in the next series of lectures, we're going to move on to the more advanced method and more robust method of creating a Matplotlib figure object, and then using object-oriented programming methods to add a set of axes to it. So, right now we've learned the very basics of how to run a function with plt.plot in Matplotlib. Now let's go ahead and shift gears to the more advanced and robust methods that are available to us in Matplotlib. If you have any questions, feel free to post to the forums. I'll see you at the next lecture.